Now we are starting section 5.4, surface area of a cylinder. So first up, let's look at the definition of a cylinder. It is a three-dimensional object with two parallel and congruent circular bases. So let's break this down. Parallel and congruent circular bases. We've got three different descriptive words for our bases. Parallel, to start with, means that the bottom of our cylinder is parallel to the top of our cylinder. They are, if you were to look at the cylinder from the side, it would look like a rectangle. The top of the cylinder is parallel to the bottom of the cylinder. Congruent means that they are the same size and shape, and circular means that they are circles. If you look straight down onto a cylinder from above, you're going to see a circle. So that's what we're looking at here. So congruent means the exact same size. So this is a diagram here of a cylinder with two parallel and congruent circular bases. So that's what we're talking about when we're talking about a cylinder. Example number 1, determine the surface area of a right cylinder. Estimate the surface area of the can. So we've got a can here that is, for our purposes, considered a cylinder. It has a height of 11 centimeters and a diameter of 7.6 centimeters. So let's take a look here. We can break the surface area of the can, that's the outside areas of the can, into three pieces. We've got two circles that are identical. They're congruent circular bases. And then we've got an area of a rectangle as well. So when you look at the cylinder, the 11 centimeters is the height, the width of it is the distance that it takes to wrap itself around the circle. So we call that the circumference. So the length of our rectangle is the circumference, and the width is the height that's given. So as an estimate, if we've got a 7.6 centimeter diameter, we can estimate that to be 8. And if we cut that in half, our radius is approximately 4 centimeters. And we're going to use pi as 3 for our estimate. So the area of the circle is pi times r squared. So in this case, we're going to use 3 times and then 4 squared, or 3 times 4 times 4, which 3 times 4 is 12, times 4 is 48 centimeters squared. Remember, that is for one circle, so we're going to double that, and we're going to then have 96 centimeters squared for the area of the two circles. The area of the rectangle, well, we're told that it's a height of 11. We're going to use 10 as an estimate value, and then we need to figure out, well, the circumference. We know that the circumference is pi times d, and so then length times width of the rectangle becomes circumference times the width. Circumference is pi d times w. Pi we're going to use as 3. Diameter we're going to estimate to be around 8 because it's actually 7.6. And width we're going to estimate as 10. So 3 times 8 is 24, times 10 is 240 centimeters squared. So that's our estimation of the different shapes, but now we have to put them all together. So 96 centimeters squared for the two circles. So we're going to put that down here. Plus the area of the rectangle, which we said was 240 centimeters squared. When we add those together, we're going to have 336 centimeters squared as our estimate. So the estimated surface area of our cylinder is 336 centimeters squared. So that's our estimate. Part B is, what is the actual surface area of the can? Round our answer to the nearest hundredth of a square centimeter, so that's 2 decimal places. So we can use a net as well to draw this out. That's another technique rather than drawing the individual shapes. And in this case, we would have 2 cylinders on either side of a rectangle. Diameter is 7.6 centimeters. And then the height of the can here, the distance between the two bases, is 11 centimeters. So find the radius. Well, diameter is 7.6. Divide that by 2 to give us the radius. So 7.6 divided by 2 is 3.8 centimeters. There's our radius. So now we can use that in our actual calculations. So area of one circle, 3.14 times radius squared. So 3.14 times 3.8 times 3.8. And that's going to give us an answer of 45.3416 centimeters squared. Again, that is for one circle. We're going to double that because there's two identical circles. So then when we do that, 45.3416 times 2 is 90.6832 centimeters squared. So that takes care of the circular bases. Now we need to figure out the rectangle. Again, length is equal to circumference, or pi times d. So 3.14 times the diameter, 7.6 centimeters. And then it's multiplied by the width, which in this case was exactly 11 centimeters. So to calculate that out, 3.14 times 7.6 times 11 gives us an answer of 262.504 centimeters squared. So now we've got two numbers. We've got the circles and we've got the rectangle. We have to add them all together to get the total surface area of our cylinder. So circles, 90.6832 centimeters squared, plus the rectangle is 262.504 centimeters squared. So add those together, and we get a total of 353.1872 centimeters squared. Now remember, we're rounding to the nearest hundredth, or 2 decimal places. So 2 decimal places, look to the third digit. It is 5 or higher, being a 7, so we're going to increase the 8 to a 9. 353.19 centimeters squared is our final answer for the actual surface area of our can, which is not bad. Our estimate was 336 centimeters squared. Final answer 353.19. Those are actually pretty close together, within 10% or so anyway. And so let's keep looking. Next up, there is a formula we can use. Rather than having to draw out the pictures, we can just use a formula. So the formula for the surface area of a cylinder, SA is surface area, is equal to 2 times pi r squared, so 2 times the area of the circle, plus pi dh. Pi times d being the circumference, and then h being the height of your cylinder. So, as I just said, SA is short for surface area, and you'll frequently see that. You might see TSA as well, total surface area, as a marking. So with our cylinder here, the tin can, we can take our formula. We know the diameter is 7.6